Imagine that. You're piloting a fragile spacecraft, 18 billion kilometers from home. Suddenly, you hit an invisible wall where temperatures soar to 50,000 degrees Kelvin. That is almost 10 times hotter than the surface of the sun itself. It sounds like a death sentence, instant vaporization in the dark void. But astonishingly, both of NASA's Voyager probes flew right through this cosmic furnace, and they didn't even melt. How is that possible? The core science lies in the near vacuum of deep space. At the very edge of our solar system, the scattered particles carry a massive amount of energy, creating that extreme heat. However, there are so few of them floating around, they simply cannot transfer enough energy to destroy the spacecraft's metal hull. It is like quickly swiping your bare hand through a tiny glowing spark. You know the energy is there, but you remain completely untouched. Welcome to the edge of the sun's domain. Imagine that. Our sun isn't just a distant star. It is a living, breathing heart, pumping a constant stream of charged particles into the cold void. This is the solar wind, and it inflates a massive protective bubble around us called the heliosphere. The solar system doesn't end where the planets stop. It extends much farther into a realm where the sun's influence finally fades. Voyager 1 traveled for 35 long years through the frozen silence of the outer reaches before it finally touched the edge of this domain in 2012. 6 years later, Voyager 2 followed, crossing the same boundary at a different point. The core science tells us this boundary, the heliopause, isn't a fixed, solid shell. It is flexible and dynamic. During a solar maximum, when the sun is hyperactive, it pushes harder and the bubble expands outward. During a solar minimum, the pressure weakens and the boundary contracts. Our entire solar system is, in a way, breathing, pulsing against the immense pressure of the galaxy itself. Imagine that. You spend decades building a map of the universe, expecting a chaotic mess of magnetic storms at its edge. But instead, you find perfect, seamless harmony. As the Voyagers crossed the boundary, they encountered what scientists call a collisionless shock. In this vacuum, where there is no air or matter to collide, electromagnetic forces take over. Magnetic fields become compressed, they snap, and rearrange in sudden, violent bursts of energy. But the real mystery was the direction of the field itself. For years, our models predicted that once we left the sun's bubble, the interstellar magnetic field would shift in a completely different direction. But Voyager 1 recorded something impossible. The fields were aligned. At first, scientists thought it was a coincidence. But when Voyager 2 crossed billions of kilometers away and saw the exact same thing, the old theories collapsed. Our sun is not an isolated island. It is deeply, magnetically intertwined with the Milky Way. We are more connected to the galaxy than we ever dared to imagine. Imagine that. You're living inside a giant, invisible fortress. Outside these walls, a relentless storm of deadly radiation is constantly trying to break in, and you never even knew it. The galaxy is not a quiet place. It is filled with galactic cosmic rays, high-speed particles moving at nearly the speed of light. Without protection, these rays would tear through our atmosphere, damaging our DNA and frying the electronics we rely on every day. This is where the heliosphere becomes our ultimate guardian. It acts as a massive deflector shield. When the sun is active and strong, our solar bubble inflates, pushing these dangerous particles far away into the deep void. But when the sun weakens, the shield contracts, and more radiation leaks through, posing a threat to our satellites and astronauts in orbit. Knowing how this boundary behaves isn't just about space science. It's about understanding the survival of our civilization. We don't just orbit a star. We live inside its armor. Imagine that. You are the ultimate time capsule, drifting into the eternal silence, carrying the heartbeat of a world that might one day be long forgotten. The Voyagers are aging, their nuclear hearts are fading, and by the early 2030s, they will fall silent forever. But they do not travel alone. On their hulls, they carry a golden record, a message of peace, music, and greetings from Earth to anyone or anything that might find them in the distant future. As one chapter ends, another begins. NASA is already preparing the IMAP mission to map the boundary from afar, and even more ambitious, the interstellar probe, a vessel designed to travel 20 times farther than Pluto, to see what lies in the true deep dark. Voyager gave us our first glimpse of the edge, but the full picture is still waiting to be painted. We are a species of explorers, and though our messengers may fall silent, our curiosity will never stop reaching for the stars. Imagine that.